Hi, my name is Alejandro Pérez, and this is the AI Coffee Podcast. Every 2 weeks, we will have one episode regarding one disruptive aspect of technology and artificial intelligence for the time to drink a cup of coffee. Today, we have a very inspirational guest. He is Sam Ward. Welcome.
Hi, Alejandro. Thanks for having me. Really looking forward to our conversation.
Sam Ward is an expert in AI and head of research and development of Enate, a company that works with AI. And I suppose that we are going to talk about this company a lot during this conversation. But first, Sam, I have some questions, some questions that I was thinking about when I was looking at your personal story, and from this conversation that we had a couple of days ago, talking about your experience. So maybe also for the audience to make you know you how has your passion for artificial intelligence and technology driven your career, so on?
Well, wonderful. I think it's all I've ever known, to be completely honest. I think I worked out very early on that I wanted to be involved with technology from the first time I touched a computer, probably about the age of 5 or 6, and I started writing code. And even from a young age, I think that was we wouldn't have called it AI or machine learning back in the I suppose the early stroke mid 90s. It was still very much heuristics and other kind of more statistical approaches. But I was always trying to push the bounds of coding and my understanding of it. And the thing that struck me very early on, which I think has stuck with me, since, is in languages we have conditionals, we have ifs and we have when loops and while loops, but we never had a why loop, and that was something which struck me from a very young age that was missing. And I suppose really formatively that was the why is the root, the seed of AI, I suppose, that advanced reasoning. Why are we doing something? Understanding why we're doing it allows us to make decisions better. So it's really all I've ever known from a very young age, and I've taken a very meandering path through technology. I've done an awful lot of different things, all of which have been underpinned by understanding data, working with large data sets, and delivering and trying to shape and find patterns or value in that data, which is the playground of AI now. That's the underpinnings, the bedrock of AI.
That sounds amazing that you were coding already when you were so young. Actually, I mean, where did you learn coding? Was it at school or
No,
just on your own? How was it?
no. I'm very fortunate to have been exposed to technology from a very young age. Most of my family are engineers, or not software engineers, but engineers in the truest sense of the word. And that meant that we had CAD from a very young age. So we had access to computer-aided design for whether it was building physical components or working with milling machines or lathes. And that exposed me, I suppose, at a very young age to some quite powerful computers, because you've got to remember that machines had to be relatively powerful to run CAD software. And it meant that I had a playground and a rudimentary understanding of mathematics and kind of systematically understanding a problem and thinking through the problem space of how do I solve this, sequentially, procedurally solve this problem. So I think that was why, or I suppose I'm very lucky in that regard. That's how I got exposed to it. And then from the age of 6 to, I would say, 12 or 13, I was entirely self-taught, starting with the base building blocks, Basic and Bash and shell scripting, and very quickly moving on to Visual Basic and with grand designs of being a game designer, which never happened. Ideas of being a games a software, kind of a games designer, that never came to fruition. But started working with Visual Basic, and then C sharp, C, Python. So I was always trying to find a better tool to bring my ideas to life, depending on what I had access to. Whichever system I was writing code on, I wanted to find a tool. So it's
No, that sounds really really impressive because you know already a lot of languages of coding. But how about university? Because I think that you told me that you studied physics and mathematics.
yeah,
I
my,
mean, why
my
didn't you study computer science, for example?
for sure, great question. I I got disillusioned or rather, I wasn't really motivated in education to do computer science. I was um, I was doing some pretty advanced comp sci stuff when I was 12 or 13, and it didn't really feel like I would uh, arrogant of youth. I would say, didn't really feel like I would learn more by going to university. And at the time, I was fascinated by physics specifically, kind of particle physics and light specifically, um, and optics. And that was something I didn't understand and had no real uh, background in, and that was a more interesting pursuit. The irony being that to do a lot of physics, you have to understand mathematics, and then when you're building models, it then takes you back into coding. So there's this interplay, right? But I think what it all stems from is problem solving, trying to understand or push the boundaries of things I don't know, right? Ironically, understand less is always been the goal. Know more but understand less, I think, is the basis of scientific discovery. I think that's the point. Um, yeah,
Yes, I understand you because, as I told you, I'm also a physicist. And for example, when I tell my friends and relatives, usually what did I learn studying physics, um, I usually say, like a joke, like I learned why the sky is blue or something like that, because it's usually something that people make this
yeah.
question from, and it's quite complicated actually, like why it's blue. But when you study this, you say that you like it optics, for example, and when you study this and you understand it, it's like, wow, I'm understanding the rules of the universe, and that's
And it's
completely
it's it's
amazing.
no different to coding, right? I think that's the because you're trying to understand. You're building a universe. You're building a pocket universe, an environment. You're writing first principles. You're establishing laws or rules within your code, and it's very similar to understand. And that's why there is physics is ultimately hacking the universe, right? It is the same mentality of understanding what rules can I exploit, what what things can I discover to almost hack a result. And that I think I mentioned before when we talked, my initial um, vocation was in cybersecurity, which I got into through mathematics, which I think is a fairly common path for cybersecurity. And that again, it's the same mentality, right? I want to understand this system to the point where I can manipulate or change it, um, or really just understand it. Hacking in the truest sense of the word, I think, is something which is um, often not understood, right? It's exploration for the sake of exploration. It's not about damaging or breaking. It's how do I truly understand, these very esoteric, back in those days anyway, it's a bit different now, very esoteric different systems. I also love that because it presented me with problems that I hadn't seen before that I had to code around, or environments that only supported a certain language, you know. So I had to go and learn that language to code in that environment, right? You know, that was a great way of learning very, very quickly.
Yes, I get your point because I know I see, and I think it's also that maybe the audience could see that you are a person that you are really interested in learning new things. You are really curious, and of course you have like different scenarios. You learn from nature. That's why you study physics. You learn from how an algorithm is made. So that's also why you are interested into computer science. But also, let's move to the corporate world because And now, I mean, you are like you are head of research of a startup, right? Of Enate.
Yeah.
I would like to know what are the key challenges and the opportunities in implementing artificial intelligence solutions, or I mean, you mentioned cybersecurity, but whatever solution that comes from science, that comes from this curiosity, to the corporate world. How does it work?
I think that really does depend on what you're trying to implement and who you're trying to implement it for, right? And there are some companies that are more, I hate the term tech savvy, but more aware um, of the value of AI than others. But really, the challenges of it are kind of broadly the same. It's about how hard you have to work to solve those challenges. I think that's the only difference, and that's normally around education and understanding. So the biggest one that I've experienced is data quality and availability, right? Um, and this is in more traditional AI pursuits. When you're looking at narrow field AI and you're trying to train a specific model around a certain outcome, availability of data is something which is very, very hard. There is often there isn't availability, and typically in the corporate world as well, you're often asking customers for that data, and there's an awful lot of red tape and hoops you have to jump through to acquire that data, whether it's sanitized or policed, so that you can build your model. And then it's quite a long distance between implementation and customer, and that conversive loop, as it were, that you need to have, that feedback loop of showing a model, testing a model. It takes a long time to implement. So data quality and availability is probably the 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 hardest, outside of kind of educating people why AI is a good solution, right? I think the trickiest thing, and more often than not, the thing I spend the most time on um, is trying not to use AI, right? Because I think a lot of problems don't need AI to be solved. AI solves some very specific problems in some very specific ways, but often if you're forcing your problem into using AI, then you'll hit the issues with data quality and availability, right? Because the problem you've got doesn't really require AI. It's statistical. It's a more traditional analytic you need to go down. Operational research, for example, optimization, standard algorithms that can be applied. And when we look at AI, we're often having to force and reshape data. Now that works great for some data, but quite often that upfront, is this an AI problem, is the first question. And subsequently it's then getting buy into AI, and you've got all the normal questions, black boxes, how does it work, understanding the algorithms, and then I guess the other big one is skill gap stuff, right? So finding the people that are qualified and able to build those solutions, is not that they're in high demand. They are in high demand from some very big companies that can pay an awful lot of money. Um, uh, Luckily, I find that you tend to find people that work in AI that are more, they're more about the problem than the money. So you if your problem's interesting, people like working on it. If your data's interesting, people like working on it. If you've got a big data mass that exposes, and I can think of one off the top of my head. If you're looking at uh, GPS information from cars, or you've got a direct line into the sensor information from cars, right? The information you can get from that, and the value you can extract, and the models you can build from it are fascinating, and that'll attract a lot of people. If you're looking at some more rudimentary natural language stuff, which is less exciting, then you'll have trouble attracting people to build your models. And then the typical kind of explaining what AI is, and onboarding people. That's also a hard part, but it's not that hard. That's more about demonstrating outcome. Sorry, and I suppose one final one is communications around AI. We're having this conversation now, which is quite often engineers that are very good at building AI aren't the best at communicating around AI. So you've got this paradoxical gap, right, where you might have some brilliant technology, but you've got a very hard job explaining that in a way which non technical people understand, and they're often the ones that you have to get buy-in from. So it's all the normal engineering problems that you've got, plus some maths, more or less. I think that's what the challenges have been, certainly throughout my career in AI.
No, that sounds really interesting, because I mean the purpose of this podcast is that to create this bridge between technical people and non-technical people, which is usually really complicated sometimes, but it's really useful, because actually I realize nowadays there are like many people talking about AI due to ChatGPT. But almost no one know exactly what it is, because it's like I already saw many different products and places that use apparently AI, but actually it's not. It's simple statistics or math, or even a really logic algorithm that creates rules, but like nowadays the trendy name, the trendy topic is AI.
Yeah,
So everything is AI. I'm really a
it's
little bit tired about that.
no, that's entirely fair, right? I think the running joke for years in this field was that, I don't know how true this is maybe complete nonsense, but the running joke was that the most convincing chatbot for years was, I think, 900 nested if then statements, or 9,000 nested if then statements, because that captures an awful lot of the search space, right? And that was the most convincing AI chatbot. There is a lot of misbranding of more traditional data science in the AI space, which makes it murkier and harder for people to really understand what AI is. And specifically narrow field AI, it's general AI is something which I think is easier to communicate around, right? Because it's a more general model, and in theory, it's a closer human analog, right? So we can as people understand it more readily. Narrow field AI is almost is almost too finite, right? It's too myopic for people to. People don't think in those terms, right? We don't really think, why do I understand that shape, or why do I understand that is the meaning of this thing. That learning is done, right? We are leveraging the learning that exists within our own heads, to work backwards and rebuild that learning, and really think about how learning is built, and how our brain has been trained over the course of our lifetime, is something which is not intrinsically easy to understand. It requires a very specific kind of mind, or it can be trained and takes longer to train and understand. And I think that's why we see kind of a challenge in people in communicating AI to people. And there's also the other problem, which is people think AI is magic, and if I just show it enough data, it'll work it out, which is not true at all. There's a there is a big disconnect between people that and I would say understand AI and what people think AI is, and that leads to all the sorts of wonderful conversations around AI is going to take over and we're going to lose all the jobs, and it really isn't. It's a very flimsy, uh, or not flimsy. Flimsy is the wrong word, but it's a very discrete kind of set of use cases that we have currently. Generally, AI is opening that up, but it's not. It doesn't mean that we're signing over our liberty, or signing over our futures to AI currently. It still requires us. I think now more than ever there is the opportunity for interplay between AI and people, and that has played into our corporate journey in Enate as well. That's why we've managed to, with Gen AI and generative AI, managed to really start adding value back to people immediately.
Hi, it's Alejandro Pérez, host of the AI Coffee podcast, and I have a very short message to you. Sorry for this interruption. Please, as this is an independent project, it will be really important for me if you could subscribe to the podcast. You could also share with your friends and relatives. And please, a very important thing is to subscribe to the AI Coffee newsletter at alejandroperezperez.substack.com. It will make this project bigger and bigger, and of course, it will create more valuable interviews for you. Thank you very much, and let's continue the podcast. Okay, that sounds really a good approach, actually. And I was wondering, what about Innate? Can you explain more about the concept of Innate, the company you are working on, and how it empowers businesses throughout workflow optimization using AI? Because that's what you actually, that I extracted this part from LinkedIn. So, how does it work?
Sure, for sure. So what is Enate? Enate is a business process uh, orchestration platform, and really what that boils down to is managing business workflows and optimizing and increasing efficiency of business workflows. The uniqueness in Enate is that it does that with both digital and human workers under one platform, right, representing the same space, which automation is a big part of business these days. And previously, I worked as a principal engineer for an automation company, so I understand the automation aspect and the value of the automation aspect. The trick has always been, how do you get your robots and humans working together? Because robots typically work at a different atomic level to humans. Um, we there's no real kind of standardization between human and robot. By that I mean a robot might work on 500 of the same task. A human works on one task at a time and can be quite dynamic about which tasks they pick. So bringing those two things together in one platform is actually not that easy. Innate does that in some really interesting ways. It allows people a single pane of glass to view their entire business process workflows and indeed their entire business, and start to optimize and find efficiency themselves within their workflows. A great example might be, um, uh, and one that I've had personal experience with, is the mortgage application workflow, which traditionally is a very linear workflow, and we think of it in traditional sense when people are working on it, is that we travel from A to Z and we go through these gates and we collect data at these gates. Well, when you look at that workflow and you have it laid out in front of you and you can understand who's working on what and what they're contributing and what systems you're interacting with, you can very, very quickly see that actually maybe we can do steps 3 and 4 at the same time as step 1. So we've removed a huge chunk of time. Or do I need that data when I get to step 5? Well, maybe not, but I definitely need it when I get to step 6, so I can accelerate quickly. And then by looking at that kind of landscape and seeing your workflows in that way, businesses start to inherently understand the way their business works a bit differently, as well as the good stuff around capacity and understanding who's working, when they're off, who's available, who could do this work. It's that's the core of the product. And on top of that, then we implement AI, and that's kind of my world. Beyond the obvious optimization problem solving stuff, which I think is more operational research of who does what when, typical kind of boring maths, TSP, traveling salesman kind of stuff, or you know more standard kind of optimization algorithms or shaping data and bin packing stuff. We then get into the implementation of AI on top of that, and that comes in some different flavors, or we implement in different ways. And really, that's around the common problems we see within businesses, or not problems, the common challenges businesses face. And they're very, very human challenges, which is interesting. So it's to do with understanding contents of emails, understanding contents of documents, um, decision making. Why, if I'm in this state, what's the next state that I go to, right? Understanding how to categorize or sort data. Um, that's where we implement and use AI. So we can categorize emails when they come in. We can say, okay, that's definitely a complaint, or that might be to do with a sales ticket, and we can route it directly without anyone ever reading the email. We might care that it's an angry email or a happy email or a sad email, and that affects the way that we route data. It's a very human. Ironically, we're using AI to do some very human things. Maybe we want to analyze and pull information out of a document. That's something else that is inherent and native within Innate. All of those things are part of the AI offering. So really, what we're doing is augmenting the user, um, working with them to make their experience better and make their job easier within the product. in the background is where we start looking at the more heavy lifting kind of around ontologically understanding their business, making recommendations, suggestions. That's deeper, right? But that's one the trajectory that my job goes in, right? And that's the path of travel for Enate, and that's what I'm working on. That's the future stuff, right? Right now we implement and we use kind of generative AI to give some really immediate valuable outcomes. That's how Enate uses it and what Enate does. It's unique, I think, in the way that it couples both digital and human workers together. I don't know of any other platform that
And
can do that quite as well.
And Sam, do you have any kind of example, like any specific, because you mentioned, for example, the classification of emails or
Yeah, sure.
things like that, but do you have any specific example for the audience to make you understand better? Because, well, you talk really technically, and I think it's a really also a good approach, but maybe, I mean, what does it mean? Because again, for example, how do you classify an email when it comes from in the inbox, for example, or something more practical?
Sure. So how do you classify an email when so most of the innate starts most of the process in Enate starts when an email is received. That's the cornerstone, the trigger, as it were. So how do we classify an email? So really, it's natural language understanding, right, or processing. So the email is the content of the email, the subject is analyzed, and we use generative AI alongside some of the more ontological kind of business outcomes that we understand within Enate to map the email to a known business outcome within an organization. That might be a business unit, for example. There might be a business unit that deals with sales or complaints, and we can make sure that email gets to them faster. In the traditional kind of business world, there'll be a generic email inbox that everyone has access to, and I might be a person that's responsible for triaging an email. I might be the person that's responsible for looking at an email and deciding where that email goes. And that takes an awful lot of time and resource to commit to just triaging emails. Businesses' time is better spent on working on the outcome. So that's a very direct example of how we do classification, and how we implement efficiency savings as well. Just in AI, of course, there is other efficiencies that we make in optimization of process and even just being able to manage and visualize a workflow within the platform is incredibly valuable. But that's in AI itself, that's how we add efficiency and add value.
Yes, I think that now it's more clear that, I mean, what you do actually, it's you help organizations to work more efficiently and to not waste time and energy on things that can be automatized, because I mean, it doesn't make sense at the end of the day to spend time classifying emails, for example, or thinking about all the processes and how to make to be more efficient. I mean, it's a really hard process,
Yeah.
and it takes a lot of time, and you can make it faster and better and of course cheaper, which is a good point
It's
also.
I think the direction of travel for most AI now, and then certainly within the bigger corporations that we've talked to and I've talked to, is around augmentation and kind of um, co-piloting of people with AI, right? Giving them access to richer data, helping them make better decisions, right? It's if you've in an old traditional, if we imagine that we're all sitting around our cubicles and our desks in an office in the mid 90s, the information I have is kind of what's in front of me, right? It's my knowledge plus any information in the data that I've got in front of me. I don't have access to a wider knowledge base. I don't have access to a wider data set to help inform my decisions. Then we move to kind of actually exposing some of that data to people, but that's that's fatiguing, right? That's data fatigue. We've given people more data, but we've not really given them data and information are very different things. right? And that's something I learned very, very quickly early on in my career. Data is just raw. It has to be interpreted. Information is interpreted, right? And it's actionable. It's directed. This is important because X, Y, or Z. What we're moving into now is taking that large data mass we've got and giving that person who's in that cubicle, in that box that maybe has no more visibility, more information. So it gives them a better way to make a decision based upon experiences other people have had within the organization, based upon, other things that we know about the business that's happening elsewhere that they have no direct line of sight over. It That's what we're I think that's the direction of travel for AI in the immediate corporate business workflow kind of world.
Yes, I agree with you. And it makes a lot of sense. Actually, it worked already with Excel, for example, when it came. I mean, I cannot even imagine the world without Excel. But apparently, it was a world before Excel arrived, and a lot of people were making counts and everything in maybe in a paper or something like that, and by hand maybe, or with calculators. So now it's going to be something like that. What I see, it's like, okay, you have a very powerful tool to empower you and your work, to be more efficient, to do more things, and also to think at the important things. As you said, to think more in the information and not in data, because usually, yes, it's very different. It's very different. Understanding the patterns of a statistic or data, that's the good point, actually, and that's the value. It's in there, and not in being hours and hours creating a specific database or something like that. That is really, really a waste of time, in my opinion. Yeah.
It's not where the business value is, I think, and that's the critical part. It may be where the fun is for people like me and you, 100%, but it's not really. It doesn't really add immediate bottom line value to businesses. It's no different to having to understand how a car works, right? I don't need to understand how a car works to drive a car. My outcome is to get somewhere and do something. That's the value for me. Someone else has already built the car. I just get in and drive it, and that's similar to the way that we're treating or moving forward with AI. You have a small amount of people that do understand the space and that can offer outcomes, and then everyone else can utilize those outcomes to deliver value. And we're kind of leapfrogging that by using some Gen AI to kind of help with those, to generate those outcomes too. The beauty of the most recent round of AI and its explosion, really, it's viral the way that ChatGPT has taken over, and I think that's probably because of the type of AI or the interface to the AI, which is wonderfully different to conventional AI. There's no vectorizing, there's no shaping of data, none of that exists anymore. It's a conversation, and we are, if nothing else, creatures of language, and we all understand inherently how to talk and communicate and drive and direct and get an outcome, direct conversation to an outcome. And I think the minute that we've exposed data to that kind of methodology for querying, which is all we're really doing, a more discursive query, value is immediately understood, because I haven't got to train someone. They already understand how to get that information. It's just we've never given them the interface, and now we've suddenly given them the interface. The trick is getting the other data that is not in that modality, in that linguistic modality, into that space so it can be queried, and rationalizing it and connecting it to that kind of space. And that's where I believe knowledge graphs come in. There's a wonderful interplay between generative AI and knowledge graphs, and understanding and exposing specific data and querying it. We'll see if that is the way it goes, but that's my current impression is that.
Yeah, that's actually a good approach. We had a discussion, and I think a couple of episodes ago, about ontologies with a professor in ontologies, Oscar Corcho. So if the audience wants to know more about knowledge graphs and representation of knowledge, maybe they can go there to understand better. But also, Sam, when we were planning this conversation, we mentioned something that it's also very important, even though maybe for us that are more technical, maybe we usually try to forget, but it's there, and it's regulation and how AI. How can we work towards a more standardized approach to AI in this world where, maybe the European Union now is going to have a regulation soon, apparently, but maybe in the UK you might have another one, or even in the United States, in different states they have different kind of regulations. So how could a company like Enate or another one work in this very complex scenario?
Yeah, and I don't think anyone has an answer yet, which is the right answer. I think that's a very hard thing to understand right now, because we are in a world where we're running ahead of legislation. Right, I think we're years ahead of where legislature is around AI and regulation. And it may catch up quickly. My fear is if it catches up quickly, it'll become too strict, because there will be naturally some knee-jerk reactions, and then that'll pare back over time. I think corporations moving forward, big corporations or ones that can afford it, we're going to start seeing more kind of a chief AI officer, or someone that understands data and regulation and where their data sits, and how that data can be used and exposed. At a country level, how countries are regulating AI, it's going to be interesting. Of course, we operate all over the world. Um, we are leveraging currently, uh, technology partners and the technology itself to manage those risks, right? Because we've got control over where that technology is deployed and where the data mass is, and you know um, where our data exists. Um, but yeah, I think as we start looking at bigger organizations that operate across different territories that may want to share some of their knowledge, how that gets shared, how it gets exposed, how AIs get built. I mean, I think the field of homomorphic encryption, I think, will be something which is quite interesting when we look at how we encrypt and work on data, right? Because currently sharing data is fraught with risk because of privacy concerns. Homomorphic encryption solves for that. In that I can share an encrypted data set, you can train and build on that without ever decrypting it, right? Unfortunately, it's very, very expensive, and it's not quite yet keeping up with. But in areas, ancillary to AI, we'll start seeing. I think we'll start seeing advances, and those advances will help us deploy and use it, or de-risk the use of AI. Data, anonymization and normalization of data, right? How do we anonymize data effectively so that we can train and build AI? That's a concern. I think an ongoing concern, how we build. I mean, from a corporation's point of view, understanding what parts of our data we need to anonymize, right? Because we fundamentally cannot expose or risk that. That's critical, right? So, data architecture is at the core of my. It's core within me. I love data architecture. It's something I'm quite often. I feel like I'm talking about more than people want me to, but really that is the foundation, the bedrock of trying to work with the future regulations, understanding the architecture of data. Because if you understand the architecture of data, you understand what you should and shouldn't expose, and most of it's common sense. But if you've got a disorganized data mass or a disorganized data set, it becomes harder to work with. If you understand that all of your application data is in this space, your business data is over here, and your customer data is over here, it becomes an easier thing to work with, and you understand what you can and can't expose. It's pretty basic engineering, but it's something which I think is going to become more focused. For years, people have worked quite fast and loose with data to deliver really powerful outcomes. We need to slow down now and really consider and stop and think. I think the other big risk is overconsumption of AI, which plays into what I said earlier about not using AI. I think that's something which is overconsumption of AI in a business represents a risk. well, represents a potential risk, not a real risk, but a potential risk, because if your core business is based around a product which may or may not exist due to regulation, or may or not be able to be deployed in a certain territory or a location, or then you have a significant impact to what your business can and can't do. So it's about adding value, but doing it in as risk aware way possible. But no one has the answers.
Ye-
It's very hard to know because it's such a dynamic landscape.
yes, of course, it's a very complex question, I know, and it reminded me to actually ChatGPT in Italy, as you were saying.
Yep.
I mean, it could be banned, or the regulation in this specific country, I mean, was at that moment against a specific product. So for OpenAI, at this moment, it was maybe a problem there. So yes, it should be something to have in mind. And I really like the idea that you said to have AI, like a specific AI. How was that? Chief AI officer. That's the term that you mentioned, and I like
Yeah.
it very much.
Well,
And that's something new to have in
I made a
mind.
bolder claim about 5 years ago that I thought we'd end up with machine psychologists, which is a similar thing, but a bit more of a esoteric way of saying it, and that's because of the way that we train and consume AI. If we can't turn AI off because our business is a critical part of our business, then we can't. If we mutate in a way which we need to correct, or if we want to try and correct the way that classification or prognosis or whatever it might be, we're using more traditional narrow field AI. I'll be honest, it's less Gen AI, but more kind of narrow field AI. You'll need to implement some sort of regime to correct that AI, right? How do we bring that back on target? What do we show it? What do we expose it to? How do we train it? How do we retrain to get it back into the space that we want it to, into the with inside tolerance? And that is no different to a psychologist in a way. It's a treatment. It's a plan to bring people, all the AI, back to. And a similar thing could be said about the chief AI officer, in that it's a specific person that understands the landscape of the data within a business, and what can and can't be done, and also is up to date on regulation globally, or certainly up to date on regulations in territories where the company operates, because it isn't going to be that shouldn't be the responsibility of the people building the AI, the outcomes based on AI. I think there needs to be a separation where possible. Of course, some companies aren't going to have the budget to employ different people, so you're going to have the same requirement. But it's going to be an interesting next kind of decade when it comes to how AI is implemented, I think. Certainly.
Okay, Sam. We are finishing the conversation. I don't want to take more of your time. Just a few more questions. So, um, I have one question that I usually ask to my guests is if you can give an inspirational message to someone that maybe wants to start working with AI, or wants to start working on as you are, like in developing a product in with data, with AI, with other stuff like that. Do you have some message to these kind of people?
Sure. Well, I think the first thing to say is just kind of start somewhere. I think that's the writing code is no different to writing a novel. The minute you start committing something to paper, it all becomes easier. Be aware, and accept failure. I think that's something also, which is, it sounds a bit pessimistic, but there's I mean it in the best possible sense. Learn to live with things not working in the way you think they are going to work, and learning from it. That's something which has been critical. And find something fun that you care about, that is maybe not. If you're just looking to get into AI and problem solving and flex the brain a bit in the space of AI, find a problem set which seems fun, that has no material outcome to a degree. And you're just building for building's sake. And the problem set I play with when I get a bit mentally blocked is asteroid mining, right? I think it is something we'll ultimately end up needing to do as a civilization, as a species. Are we there yet? Nowhere near. And it's a massively complex problem, because it involves an awful lot of quite complex mathematics, certainly around orbiting velocity and all sorts of different things that you can spend hours digging into, and gravity and modeling all of that stuff, which I recommend. It's great fun. But what it means, you're building. There's never going to be. You're never going to. You're never releasing a product. So there's no risk. There's no pressure for it to be perfect. But you're kind of moving through ideas and building things, which I guarantee will be of value on other projects. I think what, or in my experience, and this is generalization, some of the joy is lost in engineering these days. It's For me, it was engineering wasn't a decision, a career decision I made for money. It was because I love engineering, or I love writing code, or I love problem solving. It's just remind yourself as and when you can, even if you've been doing this like me for close to 2 decades at this point, very close to 2 decades, unfortunately. You tend to fall out of love with the work occasionally, and it's to reacquaint yourself with why you do this. Why is this important? Why is it fun? And for me, that's normally nonsense data, like stuff like asteroid mining. It's a stupid problem, and one that will never be solved, certainly not by one person. But it gives you something to focus on without fear of pressure or risk, or almost pick a problem that's too big, almost pick a problem that you can't solve, so there is no risk of failure, and see how far you can get. To me, that's how I operate. I don't know that that's what I would recommend to other people, but I think it's a great mentality to have with problem solving.
Yes, I agree that, I mean, it's usually when we are exploring new things that we understand, like, the next step, the next talents. And I get this idea I like this idea of creating things, starting things, start coding, or even start reading code. Or even if you don't like coding, maybe it's useful to understand how it works. And maybe when you are breaking this barrier of going in, you understand that maybe you like it, or maybe not, and that's also fine, But I agree with you that there's no need to have to be afraid of creating things, because it's okay. You don't need to be perfect. You don't need to be
No,
succeeded in this thing. It's just to start, and maybe you discover that something that you like. Yeah.
there's an adage, isn't there, or an axiom? How true it is, I don't know. But perfection is the enemy of progress. It's a very trite thing to say, but it rings true. I think there's an element of just try, and ironically, heuristically, right? Try, fail, try and see how far you get, and and have fun. I mean, um, there's a loss as well of art in engineering, and I think that's a shame, and I really miss um, to me, it's both. It's the I've always thought of coding as the closest thing to magic that you could possibly have, because it's the only profession where I can take an idea and turn it through the means of no
Yes.
physical object into an outcome. And that's something which I think either gets lost or forgotten, or commercialized beyond. It just gets lost. It gets watered down. That's something I think that's worth remembering. Is that you can take a concept that exists only in your head and then turn it into a functional thing. It's not like writing it down on paper. You've turned it into a thing that someone else can understand, interact with. That's mad. It's mad, really. It's an incredible thing that you can do with nothing more than a keyboard and some instructions. It's for me, that's the thing that I was and still am constantly in awe of, is that's I can just do that. I don't need permission. I can just begin and start writing, you know. And now I would say also with the advent of generative AI and ChatGPT, you can literally have a co-pilot that sits with you and teaches you how to write better code and think about a problem and maybe present some other information or support that you hadn't thought of with your idea. That's another thing I think we'll see more of in engineering, is leveraging GPT to make our ideas better or make our code better, although better is a relative term. Optimal code and good code are very different things, and I think we could have a massive discussion around what that really means. But the concepts that I think we can leverage kind of concepts from things like GPT to help us write better tools, better in measurement to what people actually want, right? People interacting using a solution. I think that allows us to explore different things. It may even change the way we build interfaces. I think it will, to more human interfaces, communicative interfaces, discursive interfaces into data. It's going to take a while, I think, because that's a seismic change in the way that we interact with systems, and you're not going to want to log into your banking app tomorrow and have a conversation with your bank to work on your to complete transactions. You're still going to want to see the interface and understand and visualize all that data. I think over time that may change, and we'll end up with in a very different applications no longer get built. We are really just using AI to build an interface to that data in a way that we can communicate with the data. I'd love to think we get there. I think there's a bigger human resistance to that, I think, than so maybe we never get there. But that's something I think we could get to.
I think that's a good point to end up this conversation. I mean, I only have one last question that I always ask. I mean, it's a double question. The first part is easy: is how may the audience contact you if they want to, and the second part is how do you like coffee? Because the name of the podcast is the Coffee Podcast, and that's a question I always ask. Please don't say that you prefer tea, maybe. Maybe yes. And if you do, it's okay, but just tell us.
Sure. So if you want to get hold of me, they can with my on my Enate email address. That's sam.ward@enate.net. I'm sure you'll share it and feel free in the notes. That's the best way. Or reach out on LinkedIn. Completely, go for it. I like interesting questions, so feel free to fire me a question. How do I like my coffee? I think the answer to that is yes. Is in short, I'll take it however way I can get it. Typically a latte, but normally like a double or triple shot of espresso in there. And I'm a 12 coffee a day man. I have to have coffee. I function only with coffee. So no, not tea. Even though I'm English, very rarely do I drink tea.
It's funny because none of the guests at this moment have said that they prefer tea or another thing. They all said one, like they love coffee, and maybe some said all kinds of coffee also. Like, I mean, it's strange.
It powers engineering. I believe that caffeine is a prerequisite for engineers. No,
Yes,
it's good.
I might say so. Okay, Sam, thank you very much for the time. It was a pleasure having you here. And yeah, I don't know if you have any last word to say to the audience.
Not at all. Just thank you for having me. I really appreciate making the time to talk to me. So that's it. And if anyone wants to go in deeper on any other topics or ideas, feel free to reach out. I'm always happy to talk. So just let me know.
Okay, so thank you all of you for being here one more episode. If you liked it, please subscribe to the podcast wherever you are listening this episode. Share it with your friends, your relatives, and whoever you want to. And if you liked it, please give me 5 stars in Apple Podcasts and Spotify, or click the like button. See you next time, and have a wonderful day.